Hello, my name is Mei Chen Ye from National Taiwan Normal University. I'm very happy to present you our recent work about unsupervised multitask domain adaptation. So, given abundant label data, deep models are very successful in many image recognition tasks. Unfortunately, in real-world applications, not all of the datasets have ground truth labels. The technique of unsupervised domain adaptation is to transfer knowledge learned from the source domain with labels to a target domain where labels may not be available. Alternatively, multitask learning aims to learn multiple tasks to improve the generalization performance for each task. This technique has been used to improve the prediction performance on more than one different but related problems through shared model parameters or feature representations. So, unsupervised domain adaptation would like to transfer knowledge between domains, and multitask learning would like to transfer knowledge between tasks. In view that both techniques aim to improve a model's generalization ability, for example, being less overfitted to a domain or a task. One interesting question is, does multitask learning further improve the generalization ability of a model for domain adaptation? In this paper, we extend one of the state-of-the-art single-task domain adaptation method to a multitask setting. We explore whether multitask learning can help domain adaptation. So we built our method upon the image-to-image adapt framework. This framework contains multiple components. It has two encoders, fx and fy, that map images of the source and the target domains to a latent space. Two decoders, gx and gy, that generate images from the latent space to the original domains. In addition, it has three discriminators, dx, dy, and dz, to determine if one image is fake or real. Finally, a classifier edge is trying to predict labels of one sample given its representation in the latent space. Now in multitask domain adaptation, we have multiple sets of training images, each for a task. We also have multiple tasks. The latent features are used for performing these tasks. So we hope to learn features that are not only invariant to domains, but also invariant to tasks. Please refer to our paper for the technical details. In order to evaluate the proposed method, the experimental setting must satisfy two conditions. First, the datasets must contain two different but relevant tasks. Second, each task must contain data of both source and target domains. We found that FISTA datasets meets both requirements. This dataset has images of two domains for image classification and semantic segmentation. We reported the performance of 4 settings. No adaptation single task. Models are trained in the source domain and are directly tested in the target domain. No adaptation multitask. In this setting, models are trained jointly for 2 tasks, using source domain data alone. Next, single task adaptation. This is the image-to-image adapt framework. Finally, multitask adaptation, and that is the proposed method. So first, we observed that using a domain adaptation method, it significantly improved the performance. Next, using the multi-task learning setting alone without adaptation performs similarly to the source-only method. That means the generalization ability of the model trained with the multitask learning setting does not reduce domain shift. Finally, the proposed multitask adaptation method performed the best. The results for semantic segmentation are consistent to what we have observed in image classification. So we conclude that multitask learning can enhance domain adaptation. That's the end of the presentation. Thank you for your listening.